Hello, this is my data structures final project. Let's start. This is where I initialize my array. I did an array instead of a vector, which I just prefer doing arrays a little bit more. So when I did an array, I had to do a while loop to get the size for the array, and then I also have I had to clear the flag for the project data. I had to also seek the beginning, and then I dynamically initialized my array here, and then I copied all of the lines from project data to each individual location in the file array. And also got my final project. I read in the text file right here. This is how I called and timed my sorts. I used the Chrono library, which is what I researched. That's what I just found, and I use the high resolution clock function, as it starts here and then it ends after the sorts that I was doing. I was commenting them so I could do one and not the other, and I didn't want to have to and then this is where I had the duration, which I originally did seconds, but I changed it to milliseconds to match up with my group partner. Then I outputted the time, and then I'd get the duration, which was right here. And then this is when I closed the project. Okay. This is the first I did the insertion sort, which starts out with a second value, and then it compares each value before it. So it'll compare it with 23. It is lower than 23, and it can't go any farther, so we'll replace that. Then next it would go to the next value, which is 10. It'll compare it to 23. It is lower than 23. It'll replace it, and then it is higher than 1, so it'll stay right there. Then it'll compare 5. It'll compare it to 23. It'll compare it to 10. And it'll compare it to, and then it'll hit 1, and then it sees that 1 is higher. It'll stay right there, and then it has 2. 2 will go all the way through. This is the insertion sort function that I had. I kind of just copied the one that we learned in class, but I changed it from a vector to an array. And then this is where it starts at 1, and then it goes to the next. This is the for loop that loops through every value before that, whatever this value is. This is a heap sort. It finds the largest value, and then it puts it at the top of the heap, and then it'll then replace whatever it'll put that value at the very last position, and then they will swap. And then it'll do the same thing again. It'll do the max heap, and then it'll replace the very final position. Well, it also first has to sort the array to where it finds the max heap in the first place. Then you can see that here, it first calls the heap to sort how it sorted out to where it has the highest value at the top, and then it'll also then swap the two values. It'll do this loop to where it swaps the two values, and then it'll do the heap, and then it'll keep swap, heap, swap. It'll keep going all the way till it hits the end of the array. And then this was my time for the insertion sort. As you can see, it is a very long time, which is 60 seconds. It's basically a minute, which is, if you compare it to the heap sort, which is only 97 milliseconds, it is much shorter, mainly because the insertion sort has, if there's a low value that's very late into the array, then it'll have to compare it with every single value, unlike the heap sort where it'll takes the highest value and just puts it at the end. And it will be much faster, and this should be more of a consistent time for the heap sort, if I'm correct. Yeah. And that will be my